Hi friends, welcome to my YouTube channel. Hope you all are doing good. In today's video, we are going to discuss about the fresh concrete. If you like this video, please do subscribe to my channel. Your subscription would greatly help me. And coming to today's topic, without any further delay, we'll start with the introduction part. Freshly mixed material, which can be molded into any shape, we are calling it as fresh concrete. The principal properties of the hardened concrete, such as strength and durability, depends upon the properties of fresh concrete. Okay, what all the properties of the fresh concrete are there? If they are satisfied, we can say depending upon that satisfaction, the strength and durability parameters are satisfied. The criteria is satisfied. Okay, coming to the definition of workability. We can say the workability is a very important property of the fresh concrete. It is the description of the fresh concrete property. Okay, workability as per IS code 6461 part 7, we have the definition. That is, workability is the property of concrete, that is the ease with which it can be mixed, transported, placed and compacted easily. Okay, it is nothing but how easily we are able to mix that concrete, transport that from the production unit to the site, and placed and compacted easily. Okay, that is workability. The requirements of fresh concrete has to satisfy are: the mix should be stable, in that it should not segregate during transportation and placing. That is, whatever the segregation is there, the homogeneity of that should be maintained. Segregation should not be taken place. The concrete should be such that the segregation of material, see, we know the cement, water, aggregates are mixed in this concrete, but it has to be transported in such a way that segregation is avoided totally. The homogeneity is maintained throughout its transportation from the production unit to the construction site. The tendency of bleeding should be minimized. Bleeding is nothing but the excess amount of water in the concrete will just come out. During transportation, we see this generally. Whatever the excess amount has been, excess amount of water or liquid is there in that concrete will be bleeding. So that should be avoided, because that will change the fresh concrete properties, again leading to change of the strength and durability criteria of the hardened concrete. The mix should be cohesive and mobile enough to be placed in the form around the reinforcement and should be able to cast into required shape. We already read that the freshly mixed concrete is nothing but it should be ready to be molded into any shape, any required shape. It should be mobile enough to be placed around the formwork. The mix should be amenable to proper and thorough compaction as soon as possible in the situation of placing and with the facilities of compaction. That is, it should be allowing us to do the compaction in a required manner as per the codal provisions. It should be possible to obtain a satisfactory surface finish. So also the finishing should be such that the surface is very good from aesthetic point of view. So for a concrete technologist, a comprehensive knowledge of workability is a parameter to design a concrete mix. Workability is a parameter a mix designer is required to specify in the mix. Design with the full knowledge of type of work, distance of transport, loss of slump and method of placing and compaction. Whenever we are defining the workability, we should be following all of this. We should see what kind of work, what type of work. Is it for the residential purpose or commercial purpose? Distance of transport, that is, what is the distance from the production unit to the construction site? Loss of slump, we'll be doing the slump count test to this by taking a sample that is representative of whole mixture. And method of placing and compacting, that is what we are using a manual vibration or we'll be going for some vibrators like external vibration is gone or not. And what are the factors that affect workability? They are water content, that is the water that is used for the concrete mix proportions, that is the percentages or the ratios of various elements that are used from cement, fine aggregate and coarse aggregate along with the water cement ratio we are dealing with. Okay, size of aggregates, also indicating the maximum size of aggregate. Generally we'll be taking 20 mm as the maximum size of aggregate in a mixed design procedure. Shape of aggregates, if it is a rounded one or an angular one in nature. Surface texture, that is if it is having a smooth texture or a rough texture on that. Grading of aggregates, that is uniform grading or non-uniform grading we say. That is using of admixtures, maybe chemical one, or superplasticizer whenever we are using. That is, superplasticizer will also affect the amount of water we are using for that mix. And how we are measuring this workability. Generally, we do have 4 tests for the measurement of workability. One is the slump cone test, compaction factor test, VB consistency test, and flow table test. As per the IS code 1199, we are having these following methods to evaluate, to measure the workability. And generally, we also have one another topic, the main one, that is segregation. Generally, I told you we discuss about the workability parameter, but that workability is also depending upon this segregation. Segregation of fresh concrete. Segregation is the separation of constituent materials of the concrete. This is due to improper design, improper grading of aggregates, lack of homogeneity, dropping from heights, improper mixing, and excessive vibration, leading to separation of particles of different specific gravities. Generally, this is occurring because of this lack of integrity between that, is homogeneity is lacking. Whenever a material is coming out of that or getting separated from the remaining part, we are saying it as separation. Okay, so this is because of this all factors. Whenever mixing is not correctly done and excessive vibration is done, and if we are dropping from certain heights that are more than the codal provisions, and firstly, course aggregates separate out from the rest of the matrix. Secondly, matrix separates out, and finally, the material of least specific gravity, that is water, separates from the rest of the material. See, I'm just saying the material is separated based on the specific gravity of that. The more the specific gravity, the more fastly it will come out. Okay, so that is why the coarse aggregate will come first, and the last one would be water, that is coming out as a part of segregation. So what will be happening if the segregation is taking place? Concrete loses homogeneity, becomes honeycombed, loses strength and durability. Homogeneity is nothing but the uniformity, the integrity of that. Okay, how well the matter, the materials are spread in that concrete, how well the aggregate is spreaded in that. So, if the homogeneity is lost, we can say there are honeycomb, that is, a small holes would be there in that concrete mix. We can see this generally whenever it is not properly cured or whenever it is not properly placed, and improper mixing. Okay, if vibration is done more, we can see all this. It is difficult to measure segregation, but it can be observed in flow table test. In the flow table test, we are just allowing that concrete to flow on a table. So depending upon which we can see the segregation, how well the integrity is being maintained. Okay, depending upon that test, we'll get this value of segregation. And what are the remedial measures? The remedial measures are proper mix design, use of well-graded aggregates, avoiding dropping from heights, avoiding excessive vibration, and usage of mineral admixtures and chemical admixtures like plasticizers and air entraining agents. Okay, these are the measures to avoid the segregation. And next we have bleeding of fresh concrete. Bleeding is nothing but is sometimes referred as water gain. It is a form of segregation in which some of the water comes onto the surface of concrete. We see whenever the water cement ratio is more, that is the water content is more, the excessive water is there, whatever it is there, it will be on appearing on the surface. So due to this bleeding, when this occurs, bleeding is prominently absorbed in highly wet mixes, that is with water cement ratios greater than 0.7, badly proportioned and insufficiently mixed concretes. Whenever the water cement ratio is more, whenever it is badly proportioned and insufficiently mixing is done. So due to this bleeding, water comes up, accumulates on the surface, particularly in thin members like roof slabs and pavement surfaces. So result of bleeding, due to the bleeding, cement and water comes up on the surface, which is known as latents, and these surfaces will not have good wearing quality, and in the case of lifts, it becomes a plane of weakness with poor bond between lifts. Okay, bleeding channels remain continuous and are often responsible for permeability problems of concrete. See, whenever we are allowing this bleeding, the water surface, the water would be coming up on top, and there would be some small channels that are developed that will allow even the environmental agencies to enter into this. Okay, that will also allow the other water to enter into this, causing the permeability. Again, the acidity would be increased. We know the chemicals would be coming in contact with that concrete, so reduces the bond between aggregate phase and paste phase. Bleeding rate increases with time up to 1 hour or so, and thereafter decreases but continues up to final setting time of the cement. So initially it would be increasing, but after some time it would be reducing, but at some point it will again be constant, okay, up to the final setting time of cement. What are the remedial measures of that? Bleeding can be reduced by proper proportioning and uniform and continuous mixing of concrete. Bleeding can be reduced by addition of finely divided pozzolanic materials. That is, we are just filling that. We are filling the gaps and allowing the water to be absorbed by these finely divided pozzolanic materials. Bleeding can be reduced by reducing the water cement ratio. Less would be the water cement ratio, less would be the bleeding. Okay, that is it for this video, guys. If you like this video, please like, share and comment to the channel, and don't forget to subscribe to my channel. Your subscription would greatly help me. I appreciate you watching this video. Thank you.